So thank you all for joining us today for this edition. I think this is our third edition of MIT Mondays. And we are joined, give me 1 second. We are joined by Junior Peña today, who, if you've attended multiple of these sessions, you would know I don't speak to the students before our MIT Mondays, so I'm meeting Junior for the first time. And so we'll together learn a bit about Junior's journey to the PhD. And maybe I should start by saying I'm Denzil Streete, Senior Associate Dean and Director of Graduate Education here at MIT. And Junior, could you introduce yourself to our guests?
Yeah, hello everyone. My name is Junior, and I'm currently a fifth year in the physics PhD program. And I went to the University of Southern California for undergraduate. I did pure math and physics double major. And yeah.
Perfect. So Junior, tell us a bit about where you're from in terms of what part of the country you're from and sort of what interested you in physics and math as an undergraduate major.
Yeah, so I grew up in Los Angeles. I grew up, if you're familiar with LA, I grew up in the South Central area, or like 15 minutes southeast of the University of Southern California campus. Um, my parents are immigrants from Mexico. They don't speak any English, and my sister was the first in my entire extended family to go to college, and so that sort of laid the foundation for me to go to school. And in terms of why I chose physics and math, I always had a sort of an inclination towards STEM in general, like in school, and um, I don't know, for some reason math and physics always seemed like the most interesting subjects when I was in school, and um, I guess already going into college, I had an idea that I wanted to pursue a career in science, whether that would be trying to become a professor or just a research scientist somewhere. That was sort of the main goal, and I knew I wanted to do either math or physics because those are the things that interested me the most, and so that made it obvious for me to just study that in undergrad.
Nice. So talk to us a bit about, so you knew to some extent that you wanted this career um, in math or physics or math and physics. What were some of the things you were involved in doing at the undergraduate level that sort of prepared you to be competitive as you considered a PhD?
Sure. So, yeah, as an undergrad, I started. So when I got to college, I found these online forums about getting to do graduate school in physics, and so I understood that I needed to have as much research experience as I could get, and so that was immediately what I went for. I tried to hit the ground running, and so the first semester, I immediately started talking to professors and see who would be willing to take uh, an inexperienced first year students to under their wing and under a project that would be simple enough for me to just get a feel of what research was like. Um, so immediately that first summer, I did end up taking on a theoretical physics project. I didn't end up liking it, but it at least got my feet wet, and I was excited to keep doing research. And so my second year, I joined an astronomy lab. I spent about like a year or so in there. I didn't like it either, and then I ended up doing some quantum information research in a physical chemistry lab. And that's sort of where I stayed to finish my degree. So the first thing I did to try to get have a competitive application was as much research as possible, and I also did other things on campus. So I was a tutor for some time, and I also did outreach with high school students. I would go do physics demonstrations and this sort of thing. And I was also very involved with the Society of Physics Students, again with outreach, and then I eventually was the leader of the club. So those are the sort of things I did. I made sure I wanted to check off so I can have a competitive application.
Nice. And so first I want to underline the fact for our guests that while you pursued some research opportunities, at most, all of them weren't perfect fits, right? But at least you got to figure out the things that you didn't like, right? So you were able to rule out astronomy as probably something you would pursue. You were able to rule out theoretical physics as something that you may have pursued, all by exposing yourself to those opportunities along the way. So, and you ended off right where I wanted us to go next to, which was applying to graduate school, right? So many of our attendees are in the process of applying to graduate school. What sort of, if you could talk to us about how you approach that process, and what are the things, now that you're on the other side of the process, that you'd advise students who are currently putting together their applications? And we're in November, so in many cases, they have a month to finalize those applications.
Sure. So I think the biggest factor was finding programs that I was a right fit for. So at least this is how it works in physics. If you apply to a program and there are no professors in the particular research area you are applying for, so in my case, neutrino physics, there's no reason why the program would take you because there's no PI that could advise you. So when I was applying, a bulk of my time was spent on trying to find programs where my research interests overlapped with at least 2 to 3 professors in the department. Because at that point I had already, so in terms of like the written statements, that was more or less done because I had done an REU program at UChicago. I did a research experience there, and then I did the MIT Summer Research Program, and so those programs already sort of began to mold my statements in those application processes. And so the written statements were already mostly done, and I just spent a lot of time finding professors that I really found their research interesting, and I explicitly tailored my statements to those professors. So I would say, this professor is working on this, and this is why I really like this work and think it's interesting, and what I would want to spend my time doing for a PhD. And yeah, I guess in general, a lot of people apply to over like 12, 15 programs. I would say just really focus on, instead of trying to cast a wide net, try to cast a specialized net. Choose programs where you're a good fit for it, and that'll more or less optimize your chances of getting in.
Perfect. And so you talked about the RU at Chicago. Like, what are the ways in which you leverage all of those research experiences, the ones that essentially didn't lead to what you're currently studying and the one that probably initiated your interest in the field, how did you talk about them as part of the application process?
Yeah. So that's exactly right. I did an astronomy project at the Chicago RU, and now I'm doing particle physics. So the way I weave that experience in is really just talking about the practical skills I learned from those experiences and how those skills developed me as an independent researcher. So for that particular example, that was the first time I worked with a so for that project I had a high school student that wanted to do some data analysis, and the PI at the time just gave me the reins and said, uh, help the student out and get them started. And so that's the main example I use for that experience. I said this was my first time really mentoring a student and uh, realizing what it takes to be a leader in terms of uh, uh, designing a research project and also helping someone through a research project. And um, I did the same thing for my other major uh, experience in this physical chemistry lab. I talked. It was more so optics what I was doing then, and there, for example, I talked about optics is painful to deal with sometimes, and it's always hard to get it perfectly right, and that sort of just taught me the grit of like everyday research struggle. Nothing works perfectly, and research is like a roller coaster, and it's going to take a few months sometimes to really get some experimental apparatus to run smoothly and behave properly. And that's sort of what was the guiding lesson from that experience. So all the experiences that weren't particle physics, I sort of tried to find a way that it demonstrated that I became an independent and capable researcher. That's what I tried to do.
Perfect. I think that's helpful because often students don't see the connections between how they leverage the full range of opportunities they had and showing their versatility as a potential researcher to graduate programs. So you applied to graduate programs. I would assume you got accepted into multiple graduate programs. Um, Talk to us a bit about one, what are some of the factors that went into you making your decision? And then obviously you're here at MIT. What about MIT made you say yes to the MIT offer?
Yeah. So yeah, I applied to 10 schools. I got into eight of them, and at the end, I was deciding between MIT, Yale, and Duke. Um, and I chose MIT because I had done the MIT summer research program, and through the program, I got to meet three other professors that weren't my advisor at the time, and I felt like all three of their research groups were pretty good fits for my research interests, but also for in general, like socially, I got along with these research group members. So I thought, and now looking back, that was naive in a way because I only prioritized the research. That was the main guiding factor. And also MIT is such a great place because it has almost unlimited resources to do whatever you want to do, really. Um, so that was the main thing on my mind when I was deciding. Um, but now looking back, I'll say, but I, I prefer Los Angeles to over Boston, um, just based on the weather alone and a couple of other factors. But I didn't I didn't think about that as much as I should have. And people did tell me like find a place where you would be okay living for 5 to 6 years. But that was just advice I chose to ignore. Um, and so the first 3 years were definitely rough trying to adjust to living in Boston. I wasn't a big fan, but now, like over the last year and a half or so, I've grown to like the city, and enjoyed my time a little bit more here. Um, so yeah, make sure you understand wherever you end up choosing, that's where you're gonna live for 5 to 6 years probably. So make sure you can see yourself living in the place that long. Um, so yeah, that's how I chose MIT, just pretty much on research alone. And I already had through the MIT summer research program, I already had some friends and already sort of a support group here. So that was just an added bonus, really.
Perfect. And I saw Jocelyn helped us by putting the link to the MIT Summer Research Program, or MSRP, in the chat. And I believe the MSRP application is open for next summer. So if you are a junior or senior who will be returning to a campus next fall, the MIT Summer Research Program is definitely a great program that you should check out and definitely apply to participate in. So thanks for that response, Junior. So we heard a bit about your love for math and physics, your interest in particle physics. Am I getting it right? I'm an
Yep.
economist, so this is all foreign to me. Talk to us a bit about the research that you get to do. Like, what are you working on? What's your dissertation topic? Talk to us about how that research may also have evolved from you being a first-year student to where you are now.
Sure. So I work on neutrino physics. Specifically, the experiment I work on tries to measure the absolute mass scale of neutrinos. So breaking that down, what it means is, so we have the standard model of particle physics. There's 12 fundamental particles. We all know electrons, for example. And then there's the things that make up nuclei, which are what we call quarks. Up and down quarks make up protons and neutrons. And then there's another family of particles called neutrinos. So there's a cousin, there's a version of the neutrino that corresponds to the electron, and then there's two heavier versions. So actually the 2015 Nobel Prize in physics went to a particle physics two experiments that in the 90s and the early 2000s discovered this particular phenomena that neutrinos oscillate. So I said there's three types of neutrinos, and it turns out that as they travel through space-time, they somehow are able to transmute between the three different flavors. So if you have, for example, some source that's shooting out neutrinos, and then at some distance far away, you have a detector that's looking at the neutrinos. If you pick one of the three flavors to shoot out, you can measure the other two flavors at some rate in your faraway detector. And this phenomena of neutrino oscillation turns out to, in order for this to happen, the neutrino masses cannot be zero. So we know that the mass and the probability of the oscillation depends on the mass differences between the three different states. And so we know that the neutrinos are massive. They have some non-zero mass. And we even know the difference in masses between the three neutrinos, but we don't know the exact scale. So we know, for example, that the first two weigh, for example, 5 pounds apart, and the last two weigh 2 pounds apart. But we don't know if any of them, if the scale is they weigh 10 pounds, maybe they weigh 200 pounds, or maybe they weigh 1,000 pounds. We just know the differences. We don't know the exact weight. And so the experiment I work on tries to measure that absolute scale. And so in terms of my own research, so this experiment is a collaboration between about 12 or 15 so institutions around the world, all contributing resources and time and brain power for constructing the experiment and taking the data and analyzing the data. And that's sort of the level of the scale of physics experiment, particle physics experiments in modern times. It's very hard to have just a tabletop experiment that's able to contribute such an impactful result. That's why we have, for example, the Large Hadron Collider, where hundreds of scientists are all working on that and constantly producing new results. And so at MIT, our contribution to the experiment is to provide the main detector for the experiment. And so I spent my first 2.5 years or so designing the detector, prototyping, getting it to work, and trying to deliver this main detector that's going to collect the physics data. And now these days, I'm sort of transitioning more into, now that we're going to start taking data, I'm transitioning into reconstructing. So when you run a physics experiment, you get some raw output. You have, for example, some voltage or current per time, and then you need to somehow transform that into physical results, right? So these particles had this energy or this start time, and there's some process between the raw data and converting that into physics data. And so that's sort of the next stage of my thesis is doing that reconstruction process. And then the last leg, which will probably conclude next year, will be analyzing the data and trying to not the current experiment we're running will not measure the mass of the neutrino, but it will provide some preliminary physics result about some particular nuclear decay that we're looking at. So that's the general picture of my research. And I can't remember if there was another question
No,
there,
no,
but
that's good. One of the questions I was going to ask you is what excites you about the research? And then, understanding that not everyone in our audience may be physicists or understood anything that you just said. How would you describe what you're working on over the Thanksgiving table? Because I'm pretty certain your family, you got to break it down into some language that they can understand, right? So what
sure.
excites you, and then how do you communicate this research to your family members?
Right. So okay, what excites me is that, so if you look up a picture, if you just Google the standard model of particle physics, and you find there's multiple diagrams, and you find any diagram where it has the mass of the particles, each of the particles, you'll notice that the neutrino family, all of those particles have just some limit. So it'll say we know the mass is below this number, but it doesn't have an actual number there, unlike the rest of the particles. And I think it's just fun trying to sort of provide one of the last remaining puzzle pieces of this grand theory, right? Um, it's sort of like we know there's a missing puzzle piece, but it just hasn't been resolved yet. So I think it's fun trying to pursue that and sort of, it's like wrapping it all up and putting a nice bow on it.
Nice.
But yeah, so I think that's really fun. Of course, there's other reasons why people are interested in this research. Otherwise, the funding agencies wouldn't give the money for us to conduct these experiments. One, for example, is so it turns out because the neutrinos have mass, uh, when the universe was expanding and beginning to form large scale structures, right, forming galaxies, and it was starting to come together, the neutrinos had a role in that. So they were sort of like the glue that was pulling things together. And so that number specifically, how much they weigh, is important for a lot of these cosmological models and how the universe evolved and developed. So that's like a more technical reason why people are interested in this.
Nice.
Um, I just think it's a fun problem. That's mostly my personal excitement about it.
Nice.
Uh, yeah. And what was the other question?
How do you describe this research to family members over the
Sure.
Thanksgiving
Yeah.
table who have no clue about anything mathematical or, to deal with
Yeah.
physics?
Yeah. Okay. Um, so neutrinos are actually neutrinos are the second most abundant particle in the universe besides light itself. So every second, I forget what the exact number is, but neutrinos are actually being radiated out by the sun through the nuclear processes within. And so through the tip of your finger, there's something like, I forget the number, 10 million or so neutrinos going through every second. We just don't feel them because they rarely interact, and that gives you a sense of how hard these experiments are. Right, these millions of neutrinos are going through the planet and through us every second, but they don't ever really do anything. And so, working with these particles that don't want to interact makes the experiments really challenging. Um, so yeah, and earlier, as I said, that they're actually some of the most mysterious particles in their standard model. Actually, the most mysterious particle, in my opinion. Um, there's still a lot of unknowns about how they behave, and one of these unknowns, as I said, is what how much they weigh. Um, and let's see what else. So yeah, it turns out that neutrinos were introduced as a fundamental particle because they sort of patched up in the 1930s. There was a crisis about this phenomena from beta decay where it appeared that energy was not conserved, so you got more energy out than the interaction had to put in, and neutrinos sort of were introduced to save the day. And now they're a fundamental component of how physicists view the universe. uh, without them, a lot of our theories would more or less crumble. And that's why I think that's another reason why they're very exciting.
Nice. So you talked about a bit about, well, a lot about your research, right? And then how you got here. But of course, graduate school is more than just being in a lab 24 hours a day. Talk to us a bit about just navigating your PhD as a human, right? Like, what are some of the challenges you face in your sort of day-to-day existence in your program, and how have you overcome them over time?
Yes. So I think the hardest parts of my PhD so far have been um, my first year. I started 2020 right after COVID started, and so I was we had the pandemic going on, and at the same time I was trying to balance classes and also research and getting used to a new place and a new research group and a new environment. And I guess all of those factors were sort of overwhelming for me that first year. um, and then the probably the second hardest point was when I was preparing for my qualifying exam. So this is an exam you take about early or midpoint of your PhD to become a PhD candidate. Um, it's sort of from there you just do research full time, more or less, at least in physics. Um, so those 2 points were really rough for me, and the way I was able to navigate through that was, as I said, I came to MIT because I already had a good support group here. I had a lot of friends who I can rely on, and so um, yeah, I had people that can pick my spirits up whenever I was feeling down. And I did call home to family a few times, like I'm not feeling well, and they helped, they talked me through those times. And then also I'd say I'm very physically active, so I enjoy fitness and working out. And so that was one thing that became a non-negotiable during my first year and has been so my whole time here. So I prioritize exercise because it's sort of the one of the main things that keeps me sane when things are all awry. And yeah, I would say those two things are the principal things that help me through the toughest moments.
Perfect. So knowing what you know now, what is one thing you wish you knew when you were starting the PhD program?
Um,
Like it would have made your life so much better had you known
yeah,
that
yeah,
then.
yeah, yeah. I'm thinking a while because if you've done a few of these, you probably hear the same sort of advice over and over again about like time management and finding mentors and this sort. So I'm trying to think of something different. I'd say okay, I'll go to the technical side, which is I didn't realize how much easier it is to learn about a research field or a new technique or this sort of thing from actual PhD theses. Um, so I would when I sort of started onboarding with this new research field, I was trying to read research papers, and those can often be full of like jargon and really tailored to experts in the field, and that makes it hard to try to slug through and understand each term and develop an understanding. um, review articles are really nice, but you can't always find them, and so in that case, uh, I think you should just try to look up a PhD thesis about this particular thing you might be interested or looking to get into. Just because it does have all the gory technical details if you need it, but it also does. It's more verbose. It'll take its time to explain the concepts and explain everything in more detail. Um, so don't sleep on PhD thesis. And then of course all the obvious one, make sure you understand time management and have friends, a good support group, so on and so on.
Nice. So that's very helpful advice. Um, I have a couple questions left, and then we'll take questions from the audience. So if you have questions, feel free to put them in the Q&A function on your dashboard, and we'll get to them in a second. I think we have at least one question. So we'll get to questions shortly. So one of the remaining questions I have for you is, Junior, what keeps you motivated? Like what inspires you to go on? Like you're obviously dealing with an emerging field. There may be a lot of uncertainty in terms of direction, right? You're just figuring this thing out as you go. Like what inspires you to keep going?
Um, I think in the grand scale of things, I try to bring it back to that big picture of the main reason why I got interested in all of this is because I was curious and I was interested in standing at that cliff, right, that frontier of human knowledge and trying to look beyond and being able to contribute to this whole enterprise of science. So I try to bring it back there and remind myself that this is all for that main goal I had, right? What I've been striving for. But then, on a day-to-day basis, you can't always just rely on that, right? That's not. I don't think that's enough for everyone. On a more day-to-day basis, I reel it back to my roots more or less. So this is this is crazy, but I like currently I get paid more to study and learn about things and chase my own curiosity. I get paid more than my parents both combined did growing up. being immigrants, right? And so that to me, that's just like incredible. That's like a blessing. Like I just get to have fun while they had like really challenging, laborious jobs. Meanwhile, I'm just learning and on my computer. So I really, I cherish that. I don't take that for granted. So on a day-to-day basis, I remind myself of how well I'm doing just because I get paid to learn about things and be curious. And I just find that like incredible.
Wow, that's very impactful. So thank you for sharing that. Um, my final question, of course, you're a fifth year student. What's next?
Yeah. Uh, so right now I am planning to do a postdoc. Um, and actually in the last sort of 2 months or so, I came up with this new idea that I've been pursuing with my advisor, and that sort of has led down to him connecting me with people that are closer to this new research idea. And so right now there's two professors in the U.S. who do this sort of research, and so the plan is to just keep down the path and try to pursue academia as far as I can. Um, so I will do at least a postdoc and then see where I go from there. But right now that's what it looks like it's going to be.
Perfect. So thank you so much for just sharing your story with our audience. And audience members, if you have questions, feel free to put it in the Q&A. I see we have a couple questions so far. So the first question is, you explained that you had two summer research opportunities. I'm currently a junior and just completed one REU. So I have one more summer to get some experience before applying to grad school. I've heard from friends that if you already have one summer experience, it's very unlikely you'll get a second. So I was wondering how you managed to get more than one experience.
Um, I wouldn't say it's more unlikely. Actually, I so I did an REU first, and I applied to the same REU a second time, and I got in to do the REU as well as the MIT Summer Research Program. So I wouldn't say it's very unlikely you'll get a second. Um, so I would just try anyways. And if it doesn't work out, there's always the option of doing research at your home institution. There's no issues with doing that.
Perfect. And I'll just add it. I think myself, it's actually easier to get a second experience once you had the first one, right? Because PIs are usually happy that you would have had some exposure, especially if it's in the same area. You can say, hey, I did this thing last summer and I fell in love with it and I want more experience doing it. So I'm applying to get some more experience. I would say where you may find unlikely is some programs may not allow you to come through the program twice because they want to give opportunities to others. So, there are multiple, maybe even hundreds of summer research programs across the country, right? So in addition to the MIT Summer Research Program, MSRP, there's a Leadership Alliance. There are just so many other programs across the country that you could apply to. So I would say start with some of the institutions you may think about going to grad school at, see what their summer research opportunities are, and then look at unique ones in your field, right? So that if you're in physics, the Physics Society and their website may have some sort of database of summer research opportunities. Or, as Junior said, start on your campus, right? There may be opportunities for you as an undergraduate on your campus to do research over the summer, or there may be an office or offices that can help you find some experience elsewhere. So good question. The second question is, what made you decide to pursue pure mathematics if you did not like theoretical physics?
Yeah.
Or maybe is it that you didn't like theoretical physics? Like what led you down the road of pure math?
Um, yeah, so I didn't like the theoretical physics project I was given, which was in condensed matter theory. But for a while, I thought I would still end up doing some sort of theoretical work in another subfield of physics. But then sort of in my third year, I realized that that was not really what I was into. And in that case, I was sort of in too deep. I could have switched to an applied math thing or something like this, but I truly just found the classes really fun and interesting. As I said, like I'd grown up really into math, and that's sort of what where my academic curiosity was, and so that's why I continued with that. I wasn't thinking about sort of what will make me a better applicant or what will get me more jobs. It was just this is the stuff I find cool, so I'm going to study it, which is probably not the best advice, but that's the
No.
answer.
No, I think there's some value in saying follow your passion, right? In some cases, your passion could be math and physics, and you just followed the thing that seemed right to you at the time and that brought you most joy, right? Or at least piqued your curiosity, and so you found meaning in the classes, right? And I think that's usually how folks find the things that they're passionate about, and it may lead them one thing leads to the next, and then you're in a PhD program, as you said, spending all day thinking about those topics, right? Other questions. So we've answered those two questions. Any other questions that folks would have had? We have just about 10 minutes. So any other questions? Maybe I'll turn the question on you, Junior. Is there something you thought I would have asked that I didn't ask that you think would be helpful to an undergraduate student thinking about MIT or thinking about a PhD?
Sort of if there are any misconceptions or maybe applicants that are hesitant about applying to a place like MIT, or
Sure.
like I guess trying to give tips about how to get the confidence or something like this.
Yeah, yes. So I know most people are intimidated, right? And just thinking about applying to a place like MIT. So what would you tell them as
Yeah,
to why they should pursue options like that?
yeah, I would say admittedly that I was probably the least confident applicant in my year. I applied to 10 schools and I was sure that I would not get into a single program. Um, so I myself was never really confident. And I think you should apply anyways. That's a general advice here is even though there you might be full of self-doubt, that's okay. A lot of us are. Go ahead and give yourself the opportunity anyways and give it a shot. Try to just press onward really. You're not always going to be confident, but as long as you put your best foot forward and you give it your best effort, um, that's all you can do really. So just give it a shot.
Perfect. Really, really good advice. And I'll just amend that with one piece saying that for some folks, right, the path to where you are now and a PhD is not a linear one, meaning you don't move in all cases from an undergraduate student to a PhD. So that, a lot of the students I encounter feel pressured that the only way to get into a PhD program is to go straight from undergraduate to PhD, right? So the path is not linear, right? You should do whatever you think works in your particular circumstance. Some folks, for obvious reasons, need to work after they graduate or may pursue a master's degree before they apply to a PhD. So really try to figure out what's the sort of track that you would take, and to know that many people who get admitted into PhD programs get admitted into those programs after applying multiple times, right? So don't see rejection as the end of that dream, but it may more likely be that you weren't as intentional as you could have been in selecting the right types of programs that you should be applying to. So spend a lot of time thinking through, what is your background, your sort of research experiences, and what program makes the most sense based on those interests and your background for you to apply to. Any other questions? I'm just looking at the time. Any other questions from the audience? All right, I'm seeing no further questions. So what I'll do is we'll end here. I'll invite those of you who are our guests today to connect with us on social media, to send us emails at graddiversity@mit.edu, and definitely be put in the chat. If you are not a graduating senior, you should definitely be applying to our summer research program, and the link to that application is in the chat. And I know we have some upcoming information sessions on our summer research program. So please register to attend those sessions where you'd hear more details on what makes a successful application and some other details about the program in terms of length, the stipend amount, etc. So thank you all for joining us on this edition of MIT Mondays. We have a holiday next Monday, so we will resume on November 18th with another guest. And we'll see you then. In the meantime, stay in touch and email us any questions you may have. Thank you so much, Junior, for joining us today, and best wishes for a successful semester.
Thank you. Thank you for having me.
Perfect. Thank you all. Goodbye.
Bye-bye.